We can get started with some introductions, actually. Okay, so everyone, thank you so much for joining our webinar today. My name is Paul Stack. I'm from Pulumi. I'm one of the software engineers here. With me, I'm very delighted to say I have Trevor. Trevor, would you like to introduce yourself?
Yeah, hey everyone, Trevor Kennedy here. I'm one of the solution architects in the Americas for Aiven. So I work with kind of customers and prospective customers sort of evaluate our technology and get up and running on the platform. So pleasure to speak with everyone today.
And as you can see from the title of the webinar, it's building with any language, any cloud, and any open source database. So it's a very interesting topic by bringing these two technologies together. And I'm very looking forward to seeing some of the Aiven side of things. So today you'll learn how Pulumi simplifies infrastructure deployments, how Aiven simplifies database provision and management, and then how basically these two systems work really well together to be able to use your databases across multiple clouds using any languages that you actually want to. As we said, I'm Paul, and we have Trevor. You can find our Twitter details right here. I'm hoping that's Trevor's Twitter.
It is.
Okay, good. Just checking. Okay, and then we can get started. So we're very much in the era of the cloud transition today, and actually, the COVID event in general has actually accelerated that cloud transition. And there are people at different sort of levels, different parts, different variants of that cloud transition. You have some people who are very much dipping their toe in the cloud infrastructure world, where they've effectively picked up their database and their infrastructure apps, and they've moved it to the cloud. It's very private. It's very end tier, and it's maybe a small part of their system is actually running in the cloud. It's usually backed by a load balancer or something, or a direct connect into their data center, and it's an experimental approach for the cloud. You have people who've gone a little further, or maybe skipped that step completely, and they're in this sort of transitional world between VMs and containers, and it's a hybrid of public-private cloud. They're possibly taking advantage of some hosted services, some platforms as service, maybe some monitoring tools or some SaaS, and it's really starting to bring together a lot of different parts of the ecosystem. And then you have people who have gone way beyond that, and here we call it a V3 architecture or a modern architecture. You've probably heard terms like cloud native or SaaS or SOA or all these different things. And it's effectively a fully dynamic system. It's very interconnected between systems, and things like function as a service, Lambda. You're probably taking advantage of container hypervisor, more than likely Kubernetes in this space at this minute, because it's very popular, it's very prevalent, and it's a mostly public cloud system. And you can kind of test at what point you're at in this system by being able to try and run your entire system on your local machine. And if you're end tier, you can build that and run it, quite successfully using maybe containers or physical databases. If you're starting to take advantage of a bit more SaaS-based things, then your database will, or your local development machine will need to talk out to other services. And if you're in a fully modern hyper-connected way with taking advantage of things like Lambda or Azure Functions, then it becomes a wee bit more difficult to be able to run the entire parts of your system together. DevOps has effectively transformed everything. Okay, it used to be that the operations team were the gatekeepers to everything that happened within an IT organization, and it meant that they were the keepers of new systems going out. They were the keepers of new technologies being introduced. And it was very difficult for a long time in order to actually work with them. The war story here is that I actually worked for a company that used to pay the operations team based on uptime. And because they were based on uptime, they were very difficult and very hesitant to release any new features or any new systems that the developers wanted to until they were rigorously checked for weeks and weeks by the operations team. And it became very difficult in order to actually change our ecosystem. DevOps has, as I said, transformed everything, and the operations team are now the central linchpin in driving everything forward. So they're starting to create the tooling, They're starting to making sure that they work with the applications team to bring in monitoring tools. They're working with the security team in order to bring the security aspect to everything that we're doing. And at Pulumi, we're starting to call this cloud engineering. Okay, so it's taking one step further than DevOps, and it's actually bringing all of these concepts together related to delivering the system rather than the communication patterns between them. In getting here, we understand that there have been multiple ways of managing clouds in the past. Okay, we had the web console where you would click around and you would provision a few services. It is very hard to scale. It's limited to like a set of users because people would stamp over the top of each other, and it just is more for getting started and working through this. Then you have people who have moved beyond that. They've gone to CLI tooling, some scripts, some templates, things like CloudFormation, Azure Resource Manager, Cloud Deployment Manager, where you have much more improved automation and versioning, but reusability and updates are hard, so you can't really create layers of abstraction. And then you've got people who have moved to using code, infrastructure as code, and you're setting up your resources just like you're writing and releasing your software, where you're able to create these layers of abstraction through APIs or through modules, and you're starting to understand best practices around everything that's there. So what is Pulumi? Where does it come in? Pulumi, we actually like to say we're modern infrastructure as code. So we're able to embed infrastructure as code with your familiar programming languages and your tooling and your IDEs and all your setups. It's open source. It works with any cloud. And of course, as per any product, it has a paid for aspect as well as what's going on in here. And when I say it works with any cloud, we have today over 50 providers. So we have Amazon, Azure, Kubernetes, Fastly, Aiven. We have Cloud AMQP. We have actual database drivers, network drivers. We support Node.js, Go, any of the .NET core languages, TypeScript, JavaScript, and Python, which means that you get full runtime integration with your IDEs and your tools. And of course, because it's a CLI-based tool, based on your ops familiarity, you can embed it into your CI/CD workflow. So we believe that we're trying to drive infrastructure forward to the next level and try and give people that ability to create this proper experience around building and deploying and managing your infrastructure in exactly the same way that you would have to do with your software itself. Trevor.
Yeah, let me. You want me to share my screen, or do you want to continue to?
I am
drive?
going to give it. You can drive.
All right. See, are you seeing the slides over here?
I am. Yes.
Perfect. Let me go. Yeah. So, want to kind of continue on the messaging here. So the Pulumi works with a lot of your favorite tools, ecosystem tooling, cloud providers, and so forth, and that really sort of parlays nicely into what Aiven does. So Aiven lets you use the open source databases of your choice on the cloud of your choice in the region of your choice. We have a worldwide footprint. We have 24/7 operations for the support and also our technical ops and maintenance functionality. We work with 5 different cloud providers in 90 plus different regions around the world, and we are over 150 employees total. And much like Pulumi, our mission is just to simply make developers' lives easier. Everyone wants to use the latest tooling, the best and newest open source projects. But let's be honest, it's kind of a challenge to get those products up and running. It's a challenge to get them sort of running in a really highly available manner, in a cost and performant manner. And we sort of abstract all those details away from you. You have your endpoint and you can connect to it. It's that simple. And as we think about shifting to the cloud, I think this is kind of an interesting stat, because it's not just moving from on-premise to the cloud, it's actually moving from on-premise to multiple clouds. And this recent this recent report here shows that roughly 92% of organizations are actually pursuing a multi-cloud strategy. And again, when you think about supporting not just one cloud, but multiple clouds, that adds another layer of complexity that you have to sort of manage. And it's just, it's no bueno. So when you think about sort of evaluating these sort of different database technologies and offerings across various sort of point solutions and hyperscalers, I want you to think about the fact that Aiven offers you sort of a wide swath to choose from under one single roof. So Kafka, Postgres, MySQL, Elasticsearch, Redis, time series databases like Uber's M3 and InfluxDB, you can all spin them up in one place and move them from one cloud to another without incurring any data transfer costs or any downtime in that process. So just to kind of recap, basically the Aiven platform, it runs on top of the cloud provider of your choice. So AWS, Azure, GCP, DigitalOcean, and UpCloud, 90 plus different regions. We perform the sort of the care and feeding of that. We spin up the infrastructure and spin them down. Everything is, we're an API first company, so you can just hit the API to do it. You can use our web-based GUI, which I'll demo that as well. We have command line tooling for doing it, and you can also use the Pulumi provider to provision resources as well, and we'll demo that in a second. Finally, we provide the tooling to make it really easy to migrate from one region to another, or even from one cloud to another. And again, those are zero downtime operations, no data transfer costs. It's all baked into the hourly pricing for our services. Same with scaling. Really easy to scale up from a single instance to really beefy multi-node instances that scale multiple availability zones and even multiple regions in some cases. And again, it's all super simple to do through our tooling. And then likewise, much like Pulumi, we sort of pride ourselves in being sort of good sort of partners and really easy to integrate with your existing ecosystem. So whether you're using tools like Datadog or Splunk for Prometheus, or using Elasticsearch or anything that's rsyslog compatible, really easy to turn on those integrations in the console. We have industry leading, 99.99% SLAs. Actually, the observed uptime is closer to 99.997% over the past 3 years. All these sort of compliance and sort of security tooling that you would expect is also supported. So with that, let's actually switch into something that's a little bit more fun. So let me go ahead and share my screen here. And Paul, if you can confirm that you can see my screen, that would be great.
Yeah, I can see.
Okay, wonderful. So this is the Aiven console, web-based console. Very quickly, want to highlight a couple things before you dig into the code. First, if you do want to spin up an instance, it's just as simple as choosing your database type. I'll do MySQL in this case. I will then choose the region. Let's go with DigitalOcean today. I'm in the US, so I'm going to do New York City. That's probably closest to me. I can then choose from teeny tiny plans that start at under $20 a month to really beefy plans, high availability sets, terabytes of storage. In this case, I'm going to do something a little bit more modest to serve resources here. Give it a name. Hit create. And we're going to see it spin up here. So now we see it, the instance is actually spinning up. We can see the region of the choice. Again, if I wanted to go through here and create an integration, like let's say the Datadog, for instance, and click this, I have my Datadog API key already in my account. And that's as simple as that. I now have I can monitor this instance with Datadog. Likewise, if I wanted to move it from one cloud to another, Let's say, you know what, actually, my organization is moving from DigitalOcean to GCP. I can then go in here and click GCP, US Central, and we'll see that migration is going to start to happen. We have we have the blue node saying that it's going to be migrated over. So with that, let's actually flip over to the console here. So I want to do two things. First of all, I'm going to show, I'm just hit Pulumi up here to get this started because it does take a few moments to get things provisioned. Let's give it a second here. So we can see that the stack output from Pulumi, we're going to do a couple of things. We're going to provision an M3 time series database instance. We're going to provision a Lambda function. We're also going to create a Grafana instance, and we're going to connect Grafana and M3 as a data source. We can actually see data coming in. And let me flip over to VS Code. If I get the right window open here, here it is. So if we look at the actual code, I'm using Python in this case.
Trevor, I'm so sorry. Could you just increase the font size?
Oh, sure, yeah. Bit of an eye chart, huh? How about now?
Perfect. Thank you so much.
Okay, great. Yeah, let me just change my window sizes here. Yeah, so pretty simple here. To create the M3 database engine itself, I have a little helper function, but basically I've imported the Aiven library, the Aiven Pulumi library. I then say, hey, create a database of type M3, and I pass in the name of the service, the project name, the cloud provider and region I like to spin this up in, and then I can also choose the size of the plan as well. And then I have another helper function to export the details. And in addition to that, because actually, would kind of like to show some data coming into this thing, I'm using the AWS library for Pulumi. I've brought that into my project, and then I'm creating a Lambda function with the various IAM policies that it needs to have Cloud Watch actually executed on a sort of every 60-second basis. I'm actually bringing in the resource, the service URI of the M3 database, and attaching this as an environmental variable in the Lambda function so that my Python code can actually pick it up and connect to the database. Finally, I've created my Lambda trigger rule, which in this case is just basically it's CloudWatch event that's actually triggering it. And then finally, I'm going to create my integration. Stand by while I plug in my laptop. Yeah, and then finally to integrate M3 with Grafana so we can actually graph it. Again, using the Aiven library, it's just one command to actually do that integration. So let's go back over to the terminal here. Let's see. Okay, I have a couple things I've created and a couple things are still in progress. All right. So let's pause that for a second and let's flip over to the next demo that I want to show. Let me get the right VS window here open. Okay. So this is the second project that I've created. In this case, what I wanted to highlight is the ability to do not just multi-region Postgres instances and read replicas, but multi-cloud Postgres instances and read replicas. So very easy I'm just defining this in code. I could have used the configuration variables to do this, but in this case, I'm just going to do it in code. And again, I'm going to pass into the Pulumi Aiven library, the name of the master and the name of the read replicas, and I'm going to pass in the region that I want them to spin up. So I'm going to do the master in Google. I'm going to do a read replica in Azure and a read replica in AWS. this code snippet. It's pretty similar. Again, I have created this sort of helper class to sort of pass in some of the configuration parameters, so I don't have to do it every time. And then I have a for loop that actually creates the master and the read replicas. And by the way, this code sample, actually both these code samples are on the Aiven GitHub repo, and we can send links to folks afterwards. So let me go back over to the terminal here and actually ran this. I already ran this in advance. You can see that it's created the masters and the read replicas. It's masked the passwords, which I think is good. So let me go to my actually demo script to actually show that these replicas actually work and the data is actually being replicated across the clouds. So I have a very simple function here, where a script here where I'm using the faker library to actually generate some fake data. I'm going to then insert a bunch of records into that master node. Again, I do this in batch mode. That's roughly 1,000 times. And then I'm going to read. So you have my row count function, and then I'm actually going to read from the read replica to see if the record counts match between the two instances. So let me do two things. One, I created the instances, but you know what? I need to actually export these as a variable. So let me do, if I do Pulumi stack output, so I can see that
again,
things are.
If you can just raise your size, your text size. Sorry.
Yep.
Thank you.
This or even more.
That's perfect. That's fine.
That's good. Okay. Yeah. So let me go ahead and set up a couple local environment variables so I can actually run my import script. And again, I need the master and a read replica. Just environment variables using the stack output. And then I can run it. Just run.py. So it's inserting 1,000 records into the master, and then it's got the road, and then it got the road count from the read replica, and sure enough, they match. So again, we inserted 1,000 records in the Postgres instance in one cloud, and then we migrated that over, or duplicated that data over to Postgres instance in a second cloud, and it happened lightning fast, and it's really that easy. Now let me go to, okay, great. So let me flip back over to my console. Let's see, let me change the font size. Is this a little bit easier to read, or still want more font?
A tiny bit more if you can.
Okay, something like that. All right, so going back to my second demo, looks like M3 has been created. Looks like the Grafana instance has been created. Looks like my Lambda function has been created. So let me flip over to the Aiven console here. And so sure enough, I see my M3 instance is actually running here. I can click to reveal the username and password to connect to it. Let me go back to my Grafana instance. And let's actually connect to our Grafana. Actually, let me do this a little bit differently because I need the password. Let me get the password here. Okay, so let me log into Grafana. Let me go to Explorer. So you can see it right at the top here that there's a data set has been, or data source has been connected to M3. If I then go to metrics, I can see this outside temperature value. And let me go ahead and change this something to a little bit more reasonable. Last 5 minutes. And sure enough, I can see the outside temperature values being sort of randomly inserted it looks like every minute or so. Let me go back to my code so I can show you. Let me just dive into the Lambda function here real quick. So Good thing about M3 is that it's compatible with the InfluxDB line protocol format, which is essentially a CSV value in essence. And I just want to show this is like it really is just maybe 8 lines of code less because I have comments in here to pick up the endpoint via environment variable that was set in the Lambda function using Pulumi, create a metric name, in this case outside temp, assign it a random variable, and then do an HTTP post to the right endpoint. And M3, it's you can connect it to Prometheus, so you can use it as backend to Prometheus. You can use it in place of InfluxDB and sort of telegraph collecting metrics. So there's really a lot of options for using M3. But again, it's that simple to write to it. And then if we go to, let's see, if we go to AWS, sure enough, we can see the serverless function that was created. And again, I can see, let me look at the code here. And by the way, and this font size might be a little too small. Yeah, so like I said, so here's the code again. Same thing as just doing that HTTP post. I can go over to the monitor tab and I can see if we go to the error count success rate, I can see that yes, it is in fact being fired off successfully. And then finally, so let's say I want to do one other thing. Again, let's say that I decided, you know what? I actually think that this that says 8 gigs of RAM and 150 gigabytes of storage isn't enough. Again, so I want to scale up to something that's a little bit beefier, a 3-node high availability set with more storage and more RAM. Again, it's really easy to hit the upgrade button. And in this case, I'm demoing it using the console, but you could just as easily do it via using Pulumi or the command line interface. And again, you can see that I'm spinning up 3 additional virtual machines of the new size and configuration that I specified. We're then going to migrate the data over to those new nodes, and then finally we're going to decommission the current node, which is the green one, once everything is online. But again, it really is, it's sort of that simple. So with that, I think I'm pretty much done with the demo. Paul, do you have any thoughts or questions?
Yeah, so there's a couple of really good things here. Firstly, you showed that in the stack output from Pulumi, you have the secret values. Mm-hmm. So it's really important for me to say here, Pulumi, when you create a stack, so I'll take a step back. Pulumi has this idea of projects and stacks. Okay, project is the code. It's actually the resources and the layout and everything that's there. And a stack is a representation of the state plus the configuration. So a stack can be an environment. So it can be a dev stack, a prod stack, or whatever stack. It can be developer. It can be an individual. I've seen people even using it as tenants and all sorts. And when you create a stack in Pulumi, by default, whether you like it or not, Pulumi will create a secrets provider for you. The secrets provider, if you do not specify one, will be based on Pulumi KMS if you're using the Pulumi SaaS, or it will be a passphrase backend if you're using anything that's not Pulumi SaaS by default. But you can plug in your own KMS ID, your own Key Vault ID, or your own GCP KMS ID, or even you can use HashiVault in order to do it. So we try, and because we know that people are using infrastructure like Aiven, which has sensitive passwords and it has sensitive connection strings that's there, we will actually decrypt them by default. And that value that you can see in the output isn't just in the output. Trevor, if you could run the command Pulumi stack export without show secrets, no show secrets on the end, please.
Export? Yeah.
Yes, please. You'll actually see in the state, if you scroll up a little bit, you'll actually see a service URL and you'll see a ciphertext. It's just on the bottom third of your screen right now. So we actually embed it as a secret value in your state file as well. So you actually have to opt in to decrypting, which is why Trevor used the command -- show secrets, which instructs the Pulumi engine to actually decrypt it as part of the output. And we're trying to make sure that these sensitive values that you create by default are not exposed in case you check in the state file or the state file is compromised in any way, shape, or form. So the two tools kind of work really nicely together to create this secure environment. And you can see exactly how Aiven handle that in their console because they *****, and you have to opt in to show in the password as well.
Yeah, and so and like I said, so everything else you can see right here. So if you wanted to see, the plan size that I'm using, if you want to see the project SA demo, so in this case, it's the same as SA demo. All that non-secret stuff is really easy to sort of see and leverage. But yeah, you're provided with this extra safety layer for accidentally exposing credentials. And then likewise, just how I could see the sort of resources that have been provisioned. In the Aiven's web-based console, I could also hop over to the Pulumi's web-based console, and I can see for the stack, like this, my M3 stack. I can go in here, and I can also see some of the state details here, and I can also go to activity, and I can see what's happened recently and whether it's sort of been successfully deployed or failed, or resources have been added or removed, or things have been changed. So again, it's really easy to see all this stuff when you have sort of a lot of different options for how to consume this information. Yep, and if I wanted to tear down all this stuff, it's as simple as doing just a Pulumi destroy command.
I have a question about Aiven, if that's okay.
Sure.
I seen that you showed how simple it was in order to scale your database in size. Does Aiven have an ability to auto scale, or do you know of best practices that people use to auto scale the databases that they have in place?
Yeah, so we don't provide sort of magical auto scaling, and that's because we don't want people to sort of have surprise bills. So again, it's not only just sort of a developer ease of use, but also sort of developer sort of don't get fired kind of thing, because your bill's insane. So what we do in that regard is, because everything you can do using Pulumi or an API, you would simply monitor the resource utilization of that instance. So things like disk, CPU, RAM. You would then, again, you have options for tools, whether it's Grafana or Elk or Datadog or someone. You'd monitor that and then send a command to us and say, hey, scale this thing up. And this is the new plan that I want to pick based on my forecasted utilization. And then that scaling will happen in the background.
I wonder if I think it would be quite cool to build an integration with Lambda or something that based on CloudWatch metrics, it actually fires a request to because you have an API, you have an SDK, and you would actually be able to potentially get some auto scaling. But as you say, got to be careful because you could run up a very big bill based on some errant metrics.
Yeah, we work with a lot of retailers, and so the retailers say, hey, well, Black Friday is coming up, or Cyber Monday is coming up, and we know the traffic to our website could sort of 10x. We'll work with them as part of their sort of service team and support team to make sure that we sort of provision the extra resources ahead of time. That way they're there, they can service requests, but we still can sort of minimize the overall cost spent, with that.
And if to get started with Aiven today, what would you expect me to do? What resources are available that I can go and start playing with it without knowing a lot about it?
So I would recommend just signing up for an account. When you sign up for an account, you'll get $300 worth of credits that you can sort of try to spin up services with. We have a sort of robust docs page, much like Pulumi has a great docs site. And we also have an API that's documented. So for instance, if we went to api.aiven.io/doc, you can see really easy. Let's say, okay, I want to create a MySQL instance, or I want to fetch this query statistics of my current MySQL instance. I can see the endpoint. I can see sort of code snippets in various languages, curl, so it's really easy to get up and running. And this is also a good resource to go to. So if you're not familiar or you want to learn more about what are the different options that I could configure for my MySQL instance, it's really easy to sort of look through all the options here.
Awesome. So I've just posted the link into the chat, which is the Getting Started guide for Pulumi and Aiven. So the configuration required and a basic example to get people up and running. We're always willing to take feedback based on the experience around this, especially people who are using it off the beaten track of Pulumi. When it comes to things like databases and this type of platform as a service. We're very, very much interested in feedback and any bugs that you find. But yeah, so take it for a test spin, and I guess we can open it for questions if anybody has any.
Quiet group today.
So I'm going to post my mail address. Oh, Engine said they already use Aiven and Pulumi. That's awesome. Very good to see people who are here based on that. I'm going to post my mail address, paul@pulumi.com. And if you have any questions around Pulumi or getting started with Aiven today, then I'm more than happy to jump on a call and help you out. Otherwise, I guess we can say thank you so much, and we can give people back a little extra time. Awesome. Trevor, thank you so much for joining us today. It's very interesting to get a tour of Aiven and the autoscaling capabilities. I really didn't understand that Aiven actually handled multi-cloud replicas and actually multi-cloud transfers under the hood. So I'm very excited to take that for a little test drive for some of my own projects.
Yeah, no, it was pleasure chatting with everyone today. And like I said, I look forward to kind of continue the conversation with you, Paul. Like I said, just for me, I like just being hands-on and just doing things. So I, just sign up and hammer away. It's you can't really get into that much trouble.
Awesome. I will hold you to that. Awesome. Thank you so much, everyone. Take care, and hope to see you on another webinar again soon.
Yep. All right. Thanks, everyone. Bye.